Hey, welcome to The Explainer. Today, we're going to pull back the curtain on something that pretty much powers our entire world, often in ways you don't even notice. I'm talking about machine learning. Okay, let's start with something you probably did last night. You finished binging a show, and boom, your streaming service knows exactly what you want to watch next, right? It's like it's reading your mind. Or how about your email? How does it know so perfectly what's spam and what's actually important? It just sorts it all out for you. And get this, your phone. It unlocks just by looking at you. Think about that for a second. How is that even possible? Well, it's not actually magic, even though it feels like it. The powerful, invisible engine driving all of these incredible things is machine learning. So what is it really? Let's dive in and turn that magic into a method, something that actually makes sense. Okay, so here's the deal. At its heart, machine learning is the science of teaching computers to learn from data. So instead of a human programmer having to write code for every single possible scenario, we basically let the machine figure out the patterns on its own. It learns without being explicitly programmed for every little thing. Now, it turns out machines can learn in a few different ways. Let's talk about the first one, which is probably the most common. It's kind of like a student learning with a teacher. In our world, we call this supervised learning. The best way to think about it is with flashcards. Like when you were a kid. Imagine you have thousands of flashcards with pictures of animals, and every single one is labeled, "This is a cat. This is a dog." That simple idea is the key to supervised learning. And the process is pretty straightforward. First, you feed the system all that labeled data, all those cat and dog photos. Then, the algorithm just crunches through it all, learning the patterns. Pointy ears, whiskers, that sort of thing for a cat. And finally, you show it a brand new picture it's never seen before, and based on what it learned, it makes a really good guess, hey, that's a cat. And you see this stuff in action literally all the time. It's what's powering that spam filter we talked about. It learned from all the emails you marked as junk. It's behind image recognition, helps doctors predict diagnoses, and yeah, it's even used to forecast the weather. Okay, but what happens when you don't have all those neat little labels? What if the data is just a giant messy pile? Well, that's where the machine has to learn all on its own. And we call this, you guessed it, unsupervised learning. I love this analogy. Imagine someone dumps a giant box of mixed up building blocks on the floor. No instructions, no labels. You just naturally start sorting them, right? You'd put all the red blocks here, all the square ones there. You'd create order from the chaos all by yourself. That's exactly what an unsupervised algorithm does. You just hand it a massive amount of unlabeled data, and it goes to work, finding hidden connections and structures you might not have even known were there. It starts grouping similar things together, all on its own. And this is a total game changer for businesses. They use it to group customers into different segments based on how they shop. It's the engine behind those customers who bought this also liked recommendations. And it's super important for things like fraud detection, spotting a weird transaction that just doesn't fit your usual pattern. All right, our third main type of learning is a whole different ballgame. It's not about data with labels or without them. It's all about learning from trial and error, from consequences. This is called reinforcement learning. The easiest way to get this is to think about teaching a dog a new trick. When it does the right thing, like sitting, you give it a treat. That's a reward. It very quickly learns that the action sit leads to something good. So in the machine learning world, we have an agent. That could be a robot or even just a piece of software. It takes an action in some environment. If it's a good action, it gets a reward. If it's a bad one, it gets a penalty. And over millions and millions of tries, it figures out the absolute best strategy to get the most rewards it possibly can. This is the secret sauce behind some of the most mind-blowing AI out there today. It's how we teach robots to do super complex jobs, how self-driving cars learn the rules of the road, and how we've built AI that can beat the best human players at incredibly complex games like chess and Go. Okay, so you might be wondering, what if you have a situation that's kind of in between? Like you have a little bit of labeled data, but a ton of unlabeled data. Well, there's a really clever solution for that called semi-supervised learning. And here's why this is so useful. Think about it. Labeling millions of data points by hand, that takes a ton of time and money. Semi-supervised learning gets around that. It takes that small amount of labeled data and uses it to help make sense of the giant unlabeled pile. You get awesome results without all the manual work. It's kind of the best of both worlds. Okay, so let's do a super quick recap to make sure it all sticks.
Supervised learning, that's when you have labeled data and your goal is to predict something. Unsupervised, you've got unlabeled data and you're trying to find hidden patterns. And reinforcement learning, that's all about learning the best actions to take based on rewards and penalties.
All right, so that's the theory. But let's bring this all back home. Let's talk about where you see all this stuff in your actual life, probably every single day. I mean, it is truly everywhere. It's in those recommendation engines on Netflix and Spotify. It's how Siri and Alexa actually understand what you're saying. It decides what you see in your social media feed. It powers those instant language translation tools, and it's constantly working behind the scenes to detect online fraud. Machine learning isn't the future, it is a fundamental part of our lives right now. And that kind of brings us to a really big question to leave you with. As these incredibly powerful systems keep learning from our world, from our data, from our choices, from our habits, what are we actually teaching them about what it means to be human?